Dear students, in this lecture we will discuss structure of thiophene. So previously we have discussed structure of pyrrole, or it is better to represent this like this because it is a resonance stabilized structure than structure of thiophene. Today I will discuss with you structure of thiophene, which is again a 5-membered heterocyclic ring. Now if we talk about the molecular formula for this compound, then it can be represented as C4H4S. So if we have to write the diene structure, so this is again like this, but again said earlier, similar to other compounds, and this thiophene is aromatic compound. It is aromatic compound. So according to Hucker rule, it has 6 pi electrons which are d localized. So and it is a planar molecule, so that's why it is an aromatic molecule. If we talk about the resonance stabilization energy in case of thiophene, so it is around 125 kilojoule per mole. So you can see that it is quite highly resonance stabilized. And for the structure of this thiophene, I will compare the structure with the furan, because they have exactly the same structure. There is not much difference. So compare similar to furan, this thiophene, again it contains a pentagonal 5-membered pentagonal ring of carbon, 4 carbons and 1 sulfur atoms, and each carbon and sulfur atoms, they are sp2 hybridized. So this is not hydrogen, sorry, by mistake I write. So it contains 2 lone pair of electrons. Now again the sp3 sp2, I will just write highlights. 3 sp2 hybrid orbitals of carbon, they contain 1 electron each. सारे को एक एक इलेक्ट्रॉन है which they utilize for the formation of sigma bond. So sigma bond, sigma bond, sigma bond, sigma. So you can see each carbon has, it is forming 3 sigma bonds. For that it is utilizing its sp2 hybrid orbitals. Now sulfur has sp2 hybrid orbitals. Out of these 2 sp2 hybrid orbitals of sulfur, they contain 1 electron each. दोनों को लिख के है which they use for the formation of sigma bonds. These 2 sigma bonds, sulfur is making 2 sigma bonds with carbon. For that it is utilizing 2 of its sp2 hybrid orbitals. Now third sp2 hybrid orbital of sulfur sp2 hybrid orbital of sulfur, it contains a lone pair. So these electron pairs, they are actually present in sp2 hybrid orbital. Now in addition to that, each carbon and sulfur, they have one unhybridized p orbital. Okay, so p orbital of carbon contain 1 electron each, whereas we are talking about unhybridized p orbital of sulfur, it contains 2 electrons. Now if I have to represent, now I will not show the carbon atoms, I will just simply write like this. Now they have this unhybridized p orbitals. Now if you talk about these orbitals, now the orbital on carbon, they contain 1 electron, whereas sulfur has two electrons and they overlap parallelly to make molecular orbitals, and these electrons they are delocalized in these orbitals. So these orbitals they overlap. So I am showing molecular orbital diagram of this structure. So they overlap above and below the plane sidewise, and these 6 pi electrons they are delocalized, or we can say we can represent this structure of thiophene like this, where this electron cloud it is delocalized one above and below the plane of this thiophene molecule, which is a sigma bonded framework is a pentagonal flat pentagonal ring. So it is exactly similar to, you can see the structure of furan, where we have discussed that in detail. Now if I have to write the resonating structures, let us write resonating structures. Again, these resonating structures they are similar to the one in case of thiophene. So please do practice them a lot. It is all practice. These resonating structures you can learn only by practice. You have to write again and again. So this bond gets here, it gets positively charged, the electrons come here, so we get this structure. Now this will come here, this will come here, and the next structure will be like this. So positively charged, again it will come here, it will come here. So the next structure, one thing you have to remember is that in resonance we just have to move electrons, because resonance is a movement of electrons, and these resonating structures we have to separate them by double headed arrows. Okay, so these are small things that we have to remember. So again this will come here, you can see this electrons they are delocalized on each carbon atom. So these are some resonating structures of what I call it. Here comes a double bond, here comes a double bond, and the electrons they come here. So these are some resonating structures of furan. Again these can be validated by measuring the bond lengths as we have shown in case of furan. So that is all regarding structure and resonating structures of thiophene. In the next lecture we will compare the relative aromaticity of these 5-membered aromatic heterocyclic compound pyrrole, furan and thiophene. We will see which one is more aromatic and which one is less aromatic, and all these three they are less aromatic than benzene, that we have already discussed, because benzene has two resonating structures of same weightage of equal stability, whereas in this structure one structure is more stable, whereas other structures they involve separation of charges and they are less stable. So thank you very much. So in the next lecture we will see relative aromatic character of these 3 5-membered heterocyclic compounds pyrrole, thiophene and furan. So thank you very much.